So hello everyone, in this class we are going to prove two important theorems of group theory. The first theorem states that prove that a group G, compose has only one identity element. That means in a group there is only one identity element. We have to prove that. So we will begin. Proof. Suppose we have let E1, E2 be two identity elements. Be two identity elements. Be two identity elements. Identity elements. And let A belongs to group. That means we have taken E1 and E2 be two identity elements, and we have taken also an element A which belong to the group. Now A compose E1 equal to E1 compose A. This should be equal to A for all A belongs to G. This is very obvious since E1 is the identity element. If you compose identity element with any element of the group, then the element becomes same. Also, we can say A compose E2. This is equal to E2 compose A equal to A for all A belongs to G. This is the basic thing that we can say from here. Now, also, further we can say E1 compose E2. This is equal to E1 when if we treat E2 as the identity element, when E2 taken as identity element, identity element. Also further we can say that E1 compose E2. Suppose this is our number one equation, and now we can say E1 compose E2. This is equal to E2. This is our number two equation. This is when E1 is taken as identity element. Taken as identity. So this is very obvious. We have taken E1 and E2 be two identity elements of the group, and we have taken also A belongs to the group. That is A is an element of the group. Now we have also said that A compose E1. This is equal to E1 compose A. This should be equal to A. This is the basic property of identity element. And since also U2 also the identity element, that means A compose E2 equal to E2 compose A equal to A for all A belongs to G. This is obvious. We have also said that E1 compose E2 this is equal to E1 when we treat E2 as the identity element. Also E1 compose E2 this is equal to E2 when we treat E1 as the identity element. Okay. Now from 1 and 2 what we can say? Now from 1 and 2, see in the left hand side we have from the first part we have E1 composite 2, and the second part we also have E1 composite 2. In the RHS we have E1 and here we have E2. That means 1 and 2 implies that E1 this is equal to E2, which is the required condition we have needed. So E1 equal to E2, which implies identity element is unique. That means we must have only one identity element. Identity element is unique. So let's move to the second theorem. What does it say? Theorem. Prove that in a group the identity element is unique for any element. That means for every element the identity, so it should be inverse. It should be inverse. This is inverse. That means we have to prove that if an element of a group has inverse, then that inverse is unique. That means each element of a group has finite inverse. That means only one inverse. So proof. Let us suppose let G compose be a group, and you also say that A belongs to G. That means E is an element of the group. Let us suppose B comma C be the two inverses. B two inverses. of A. That means we have taken B and C as the inverse of the element A. Therefore, we can say A compose B, A compose B equal to B compose A. This is equal to identity element. This is the basic property of inverse for all A belongs to the group. Also, we can say A compose C. This is equal to C compose A, which is also equal to E. Now, see, we can say B equal to B compose C. This is very obvious. So, this is equal to B compose. In place of E, we can write A compose C. So, we get A compose C. Now, by associativity, we can write B compose A compose C, which is equal to C B compose A. This is nothing but E. That means E compose C. So E compose C, which is equal to C. In the left hand side, we have B. That means we have proved that B equal to C. Therefore, B equal to C, which implies that every element has unique inverse, which is our required proof.